All right, welcome to Chapter 6 with 6-1, Day 1. Law of signs will be the topic today. As the name obviously suggests, Chapter 6 is just a few more topics in trigonometry. Law of sines, law of cosines. You'll probably find that you're pretty good at those and that they're somewhat familiar. And then the biggest topic for the rest of the way in Chapter 6 are vectors. Okay, one word about that, kind of a big heads up going forward. That might be a topic for you that is brand new. Maybe some of you have worked with vectors. That's going to be a theme basically after the first two sections of Chapter 6, that most everything we cover is probably brand new. Okay, so these last two sections, 6-1 and 6-2 with law of sines and cosines, will likely be with that familiarity, and which is okay. That's kind of where we're at in the year, is we've hit a lot of topics that you're somewhat familiar with, and that's going to change. But you're probably going to see a lot of stuff here today that's pretty familiar. All right, before we jump into the law of sines, I'm not going to call this a proof because it's really not. This triangle I have isn't a right triangle, but it's an acute one, so there's technically like a different verification. I'm kind of giving you the outline of what a proof would look like, okay, to get to the law of sines. The big thing that I've assumed about this triangle is it's not a right triangle, because that's where the law of sines is going to take us, is kind of working with some trigonometry problems with triangles that are not right. Quick reminder with sides and angles. Remember, sides get lowercase, angles get uppercase, and the side is always opposite, the letter that goes together. All right, so I kind of split this up into two triangles. If you want, you can think of this as like right triangle number 1, and this is like right triangle number 2. So if I'm starting in triangle number 1, okay, this little like smaller right triangle that I split the big triangle up into, I could say that angle A's sine value is H over C. Okay? And if I jump over to triangle number 2, I could say that sine of C is H over A. Okay, and to make sure before you're going to continue with this here, that you're okay with that you're going to kind of, obviously I'm just dealing with letters here, just variables and no numbers, but, check that you're okay with that those are both true. A basic step of algebra would lead us to this, that the sine of A, if I multiply C by both sides, C times the sine of A is H, and then over here, that A times the sine of C equals H. And isn't that crazy? They both equal H. Therefore, I can say that C times the sine of A is equal to A times the sine of C. Okay? Now, kind of a crazy thing to do here, but bottom line is algebraically it's an allowable thing to do. Divide both sides by side length A times C. Okay, it's a constant, and I know it's not 0, so I can do this. Kind of an interesting thing to do, but the C's there will cancel, and I will get sine of A divided by A. Here the A's will cancel, and I will get that equals sine of C over C, and we end up with essentially some fractions that are proportional, which would mean if I have 3 of those 4 measurements, I could use this to get the one that's missing. Okay. Now, obviously, angle B was kind of left out. If I wanted, I could draw the height in differently. I could have done this with A or B. Could have done it with B or C. So at the end here, even though I didn't verify it, because like I said, this verification is kind of like a partial. That's the idea behind how you would get to the law of sines. But it's true for B as well. There you have it. That is the law of sines. So now that we've got the law of sines, we're going to go ahead and use it a little bit. You need to pay attention to your case. Okay, the all missing sides and all missing angles are what I have to solve for here. But here I have two angles and a side that's not in between the angles. That's called an angle-angle side case. Okay. In our last two examples, we're going to get to what we call the ambiguous case, which only comes up in one specific situation. Okay, so to kind of get ahead of ourselves here a little bit, looking at that ambiguous case, this isn't it. So I know when I'm solving this triangle, I'm getting one answer. Okay, there's one possible triangle. Okay, let me put in some angles and sides. So if that's side B, here's angle B. Let's call this one A. Let's call this one C. All right, so side length C, I'm going to have to get side length A. I'll start with angle A. That's technically missing, but because the three angles have to add up to 180, that one's a little bit of a gimme. Okay. All right, two side lengths to go. Okay. And again, thinking big picture, the reason we're not going to go with SOHCAHTOA here is you can see this is not a right triangle. Okay, so the stuff that we've done in the past in Chapter 4, not going to work. All right. However, let's say I want to find side length C. If I take C divided by the sine of 102.3 degrees. Now, as you see this, you might be thinking, hey, wait a minute. When you verified the law of sines, the sides are on the bottom. And that's true, but as long as you flip both, right? I could say over here, I got to go with B, because I have to know both of these numbers. I know side length B and angle B. That's a really important point to make here, and I'm glad it came up in our first example, that the sides can go on the top. Right? If you're going to flip it, they have to get flipped together, but they're still going to be proportional. Pretty straightforward stuff here. Multiply both sides by the sine of 102.3 degrees. You get a big mess that's going to obviously have to go into your calculator. But when you put all that in and the smoke clears, as they say, you'll have side C. And I'm just going to go to the nearest tenth. Make sure your calculator's in degree mode, but you should see it's about 55.7 feet. Okay? So we got C. And all that remains is A. And what I want to take you through this one. If you are really familiar with the law of sines, you'd be like, do we really need to go through A? Well, one, yes, we do, because the instructions said to solve the triangle, so we got to find it. But as you see this, I'm going to go with side B and angle B again. It's like the exact same thing, which if you think about it, we like that. Right? The law of sines is really consistent. If you're solving for a side, it's like the same thing every time. You get it set up, you'll probably put the side length on top. To get A by itself, we just have to take 27.4, multiply it by the sine of 49 degrees. Notice I picked that angle because that's what's opposite of side A. The law of sines, is a formula that I like to say is user-friendly, right? If you get the numbers where they go, it's really, basically what's going on is a cross, multiply, and divide, and that's really what it is every time. So if you can either get a diagram set up from a word problem, or better yet, if it gives you a diagram, it's basically the exact same setup on every problem to get a side. 43.1, obviously, same deal. I would have taken all that and entered it into a calculator. Okay? And again, that was an angle-angle side case. All right, this one luckily doesn't ask us to solve for the whole thing, All we're after is A. But here's a big thing. As I look at what's given, remember I've said, and you don't have to write it down. Obviously, to remind you when I go through examples, I will. What we're after here, based on all this information about the diagram, is the pole. Okay? And here's the thing. It kind of seems like we don't have enough information. We do. They're trying to be tricky and hide the fact that this angle right here is 98 degrees. Okay? Because it's 8 degrees past vertical. Okay? So here I have two angles, but the side length is in between, which we call ASA, or angle side angle. Okay? The next example we're getting, and you can see if you have the notes outline, it's labeled as the ambiguous case. Okay? What I need you to see here is that this isn't it. Okay, so that complicated case that we'll get into, don't have to worry about. This is just straight up law of sines. Okay? Now to get it set up, I like the side on the top. So I'm going to leave that. On the bottom here, that has to be the angle that's opposite. So that's got to be over the sine of 43 degrees. Now keep in mind, I have my one thing that's missing. So in this other setup, I have to know both. And that only leaves me with one possibility, which I'd kind of overlooked to this point. Right here. Hadn't talked about this angle up here. We're going to need that one though. But we're in great shape because we've got 180 degrees between the three. Take away 98, take away 43. That one's 39. But we need that. Because here, the distance of the shadow, that's the only side length we have. So on the other side, I have to put 22. And then I'm looking to angle C. And for this whole thing to work, I have to know what that is. Luckily, we do. Okay? And like I said on the other ones, same thing. 22, we'll multiply both sides by the sine of 43 degrees. You get to that. Big ugly mess on the right side. It's actually not that bad. Okay? Throw that into your calculator, and you would get 23.8 feet. Our best approximation that we could get for how tall that pole actually is. All right, here is the ambiguous case, okay? And I'm going to leave you hanging on it a little bit, okay? Largely because really the two solution case is the most complicated. I kind of want to talk about how that comes up, but I don't want to work through it. So you're basically going to see this ambiguous case is going to get split up between the 2 days. We'll start talking about it now, and then as far as example 5, the 2 case, we'll start with that on day 2. Let's go back to the information that we have. I have 2 sides and an angle that's not in between. Okay? Side angle. This is the case where we have to be cautious. Okay? There might be a single solution, there might be none, or there might be 2. There still might be 2 possible triangles. Okay? This is the only time, if it's side angle, which you can easily remember by, it seems like a very silly little trick, but side angle, what does it spell backwards? Okay? Ha ha ha, very funny, tomorrow I'm sure in class that you'll all be calling it the ASS case, but we do the opposite for that exact reason, but not a bad way to remember it. That's the one where you have to be cautious. All right, so as soon as I recognize this, my paper is getting split up into case 1 and case 2. Okay, now you already know, because I've told you, this is a single solution, so case 2 isn't going to happen. Okay? Side length C. Now, so let's just focus on case 1. As you set this up, you will see the only thing I can do is solve for angle B. That's it. Sine of B over 12. Now I need a pair where I know both. Well, let's go sine of 42 over 22. Okay? And then we get sine of b equals 12 times the sine of 42 over 22. And I want to come back to this. You don't need to write this number out. The bigger deal is that it will go into your calculator. That's what this equation gives us, is angle B's sine value, 0.365. Okay, so then if we go and do an inverse, the calculator will tell us 21.4, and we're like, sweet. Angle B is 21.4 degrees. Okay, all that's left is we basically have to do another law of sines, and we're going to get angle, well, actually, no, angle C is a breeze now, right? 180 minus 42 minus 21.4. All that's left is side length C, right? And we've seen the side length case a bunch already. C is going to be the sine of 116.6, which equals 22 over the sine of 42. Now, for the sake of space and the fact that you've seen 3 of these, I'm trusting that you know, okay, basically cross, multiply, and divide. Okay, because I really want to get into this case 2 thing. Cross, multiply, and divide, and you would get 29.4. Okay, even though I didn't write that one out, you should double check in your calculator and verify that you would get 29.4 inches, okay, when you solve that. Okay, and case 1 is done, and we're like, sweet. You know, we had to apply the law of sines twice, just like the other, and we're good. Okay, here's where everything comes back to. That the sine of B was 0.365. That's an approximation. Okay, and we got 21.4 degrees when we did the inverse. Here's the issue. Okay, if we do 180 minus our first answer, this takes us back to chapter 5. That was always our rule when we were solving to get our second answer. Okay, or like our second set of answers. Okay. That gives you 156.8 degrees. Okay, now my diagram looks more like a 21.4 because this is the single case. But think about this now theoretically. 21.4 degrees and 156.8 have the same sine value. Okay, to verify that, just go plug them into a calculator. Do sine of 21.4. Do sine of 156.8, and you're going to see they're both like 0.365. Could either one of those conceivably be in a triangle? Well, basically what we know is, you know, if we think about each individual angle, they have to be less than 180. But yes, in general, it's possible for a triangle to have a 156.8 degree angle. Which is the one that we're looking for? Okay? Or how would we know that the one we want is 21.4? Okay? Let's think now, based on the angles. We have 180 degrees. Okay? And we can't change 42. That was given. Okay, so we can't mess with that. Now, instead of subtracting 124, let's think about like we're trying to get this angle. What if angle B was 156.8? That would give us negative 18.8 degrees for angle C. The first case seems to have made more sense when we did 180 minus 42 minus 21.4. Okay? Because we got this negative right here, we can conclude there is no second case. All right? So when we're getting to the side-side angle with the second case, it's possible that we have it. Okay? There's no guarantee that we do. Okay? We might. This happens to be a case where we don't. So this one's a side-side angle again. However, this is more of in general. This can happen in other cases too. You should check for it in side-side angle as well. But can we get no solutions? It's possible, because our diagram may not be to scale. We may get information that it's not possible to construct a triangle. Okay? Now check out right here. Let's try to find the sine of b. I think that's the only thing that we can find. Yeah, the sine of b over 25. Well, let's see here. We would need the sine of 85 over 15. Okay? We cross multiply and divide, and we get that the sine of b is 25 times the sine of 85 all over 15. You plug that into a calculator and we get 1.66. And then we're like, all right, life is good. We got our sine value. Go do the inverse. And your calculator gives you problems saying something like error domain. Okay? Think back to basically chapter 4. How big can sine values be? 1. Okay? The numbers that it gave us, okay, because again, this diagram is not to scale, and the problem may not even give you a diagram. It is not possible to construct a triangle with those dimensions. Okay, so if you see that happen, that you end up getting like a sine value that's over 1, and the inverse doesn't work, there is a case that has no solutions. You can stop once you get to that, once you get to this, and then you can just say, no solutions. Okay? We're going to call it there, all right? And again, I'm kind of leaving you hanging on this ambiguous case. Think side-side angle. We haven't seen one where the second case is possible. There's a lot to talk about on that, and on day 2, we will start with that.